we go. So we're changing function graphs. So it changes the f of x equation. So f of x is the parent graph. I think yesterday I used orange. I'll use orange for this example. Then when they go changing it, they give it a different name. I don't know if you noticed that. If it went from Freddie to Gina, whatever, okay? It changed names. When you change things about a parent function, you change a name. That's a pattern. So if you remember from yesterday, we find the h as the subtractor, so it's really a -3. And that negative turns into the word left, and then the 3 is how many. You never put a negative number in for a move. You just say what direction it moves and then leave the units as is. And you'll make that mistake before you get it right all the time. Which is nice. Everybody feeling it clear, loud and clear? It was just an x squared, and in the x cozy, inside the function, messing with the x was a -3. And that's how we knew what the move was. So this is the change in the equation. Here is the change of the graph. Sometimes they give you a graph and you have to write an equation. Sometimes they give you an equation and you have to pick the graph. Sometimes. Depends. Or they might give you the parent function and they give you the story. Then you have to write the new function, whatever it is. Okay, the k is the outside guy here. K has no drama. K is normal. You don't have to switch any signs to think about k. K is what it is. And it is up because it's positive. And 1. So obviously, if you don't see a sign, it's a plus. So the plus changed to the word up. And the K is the up and down. And the H is the left and right. So H moves things left or right. And this is truth for the rest of your days. K moves graphs up and down, up or down. And you'll use these notes for the rest of the year, thinking about how graphs change. And you'll be able to talk about it then. Now they picked, this is a quadratic equation. It could be an absolute value equation. It could be a cubic equation. It could be a linear equation. La, 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 la. They all have that. Now the new thing that's in this template that wasn't on the front was this value of A. So we're going to color it blue. And we'll talk about it later. In an example, there's not one in this example. There's no A. This guy is the vertical I forgot the C. It's a vertical multiplier is what I call it, but it looks like another word for multiplier is a factor, another word for factor is a multiplier, but it either stretches makes the graph go taller if it is bigger than 1, or it compresses. Makes the graph go wider when its number is, without its sign, it is less than 1, if it's a fraction. Now, this is all positive things, but what if it's negative? We're going to talk about that later. So that multiplier either stretches or compresses the graph vertically. Alrighty? That's what the A guy is. We'll get there in problem 2. So let's look at the graph. We just diagrammed and talked about the equation. Let's look at the graph. What happened? Remember, the parent function has a vertex at 0, 0. I'm coloring, it isn't dotted. So I'm going to color it orange like the parent graph we've been having for examples. Then the new graph moved it, the entire set of ordered pairs, left 3. That's why this is a negative 3. And up 1. That's why this new ordered pair for the vertex is 1. Now, not all graphs have vertexes, but for this example, this one had a vertex. See? And if you're going to change a graph, all these change, but when you're picking your graph, an easy one to see which graph is right, look for the vertex change. But they all did this. Like this point here went left 3 and up 1. See that? This point here, left 3 and up 1. Like that. All points shifted. Just to say, tag this one because it's an easy one to see on a quadratic equation. So I hope you're feeling good about these ideas. So you have to be the person that writes about them, right? Somebody else is talking about them. Oh, that's simple, right? And then when you're the creator or the investigator, it gets a little difficult. That's okay. That's why we give each other practice, practice, practice. And you'll practice all year long on this. And yes, if you're really serious about being successful, it will stick. Eventually. Take a while to get used to, but eventually it'll stick. So problem 2 says, using the description as a guide, okay, we get to write the equation. So here's the parent function. So before anything changed, it's it's this picture, but now we're just going to use words. Okay, so this original function is stretched vertically. So anytime something stretches or compresses, for me it's a color-coded blue, by a factor of 3. So that means this number outside is a multiplier of 3. So what happens is the original graph just gets pulled on. So it rises faster. And so instead of 1 over 1 up, it goes 1 over 3 up. Like that, it goes up 3. So when I get, the y, remember this is the y guy, right? If I put a 3 out here, this guy goes 1 over 3 up. In other words, y gets multiplied by 3. Okay, that's the picture, but here's the story. That's why they landed a 3 out front, outside the parentheses where x lives. It's all about the vertical change. And now we're shifting down. So that is a K. When I see the word down, we're talking K. So K is the one that shifted down. It is what it is. K down 2 means a negative 2, right? I forgot to color A over here. And if there's no story about H doesn't change anybody. That's where they got the 0. Because if there's no change, you're adding 0. How do I change you? You know, if I'm going to change you not by nothing, I would add 0 to you. Add nothing to you. And that's why it disappeared in the story, because x minus 0 is just x. So now you've seen a multiplier. So you're connecting the words with the equation. Connect the story with the equation. Happy, happy? So here's one more thing that could happen. It could be shifted left. It could be shifted right. It could be shifted up. It could be shifted down. It can be stretched vertically. It could be compressed vertically. Now, we don't talk about it yet, but you will eventually in a lesson where you can stretch horizontally and compress horizontally. We'll eventually get to that multiplier. That friend is called the 1 over b, and that's an old funness. You'll know what I'm talking about when you see it, though. What happens when I want the graph to, instead of go up, I want it to go down? And that's what they're asking in this question. What will happen to the coordinates of the graph if it was reflected, and I'm going to use brown for that, lightly, across the x-axis? In other words, if my graph started up here and it went down here, how would I change these ordered pairs to look like this? This is the x, this is the y. Who changed? The x numbers or the y numbers? What do you think? If I'm going up and I flip down, who got changed? The x numbers or the y numbers? Yes, yes, you see it. Good job. Okay, so what would happen to the coordinates? The y values would change signs, i.e. the opposites. So up here, if I go to 1 over, this graph stinks. Okay, let me go 2 over 3 up or whatever. Okay, 2, 3, down to get across. The 2 stays a 2, but then it goes to a negative 3. So that's what happens when you're reflecting across the x-axis. The y values change. So to make that change, I have to be multiplying by a negative number. Guess who becomes negative? That multiplier will have a negative sign out front. Because if I mess inside, I'm changing the x values. But if I mess outside, do you see inside and outside? See what I'm saying? The inside is the x house where all crazy things happen. the outside, if that 3 was negative, the curve would flip over. Flip over the x-axis. So reflect across the x happens across the x-axis. It's the y's that change. And that's all, you know. If I wanted to reflect across the y-axis, the x values would change. It could flip sideways. Okay? It could flip from here to here. So you see the x values would change. On the x number line, they go from negative to positive. But I went from here to here, therefore the y values changed like that. Okay, you got to get in the picture. You become a point on the graph, okay, and then see what happens to you when somebody either adds something, subtract something, multiply something, whatever, okay? That's going to make you a better grapher, you understand the moves on the graph. That's all I got for you, my friends. You're ready for the 14 questions on 1.3 homework. They were due on Wednesday. I changed it to Friday since we didn't get done with the notes till today. And then, you know, the other 2 over the weekend, the 1.1s will turn into zeros if you're not done with that. And the 1.2s will have a missing tag on them. You'll have to have a conversation with me. I need it open longer. How long? And that's best on the email because I will have a record of your request. So there's no like, I told you, no you didn't, blah, blah, blah. And then if I can't get to it, you know, right now, I will eventually get to your email. I have missed emails though. So keep nagging me. Okay? I don't mind I am not offended in any way, shape, or form when you say, Mrs. Fisher, you forgot to open up that lesson. Could you please do that for me? And yes, I will send a great apology with a correction. Okay? Thank you. Have fun. This is a deep